Welcome to the Antonio Zamora podcast that discusses a variety of scientific topics. Global deluge at the onset of the Younger Dryas. The Younger Dryas was an abrupt cold period that temporarily reversed the gradual warming trend that started after the last glacial maximum. The onset of the Younger Dryas glacial conditions was accompanied by a rapid worldwide rise in sea level. In his book America Before, Graham Hancock says that most scientists are avoiding an explanation of why the floodwaters should have occurred at the onset of the Younger Dryas deep freeze rather than 800 or 1,000 years earlier during the warm phase of the Bowling-Allerode interstadial. Hancock says that intuitively one feels the meltwater floods should have been at their peak during the warming phase. So why, in this case only, do we see them at the onset of an extremely cold phase? He quotes the 2018 paper by Walbach et al., where they present evidence that deepens the mystery. Unlike for typical warm to cold climate transitions, they report, global sea levels rose up to 2 to 4 meters within a few decades or less at the Younger Dryas onset, as recorded in coral reefs in the Atlantic and Pacific Oceans. Hancock emphasizes that the point is understated, but this is a very big deal. 2 to 4 meters of global sea level rise within a few decades or less of the onset of the Younger Dryas is an immense amount of water, a cataclysmic world flood by any standard. This is a remarkable observation, so I decided to look at the sources for Walbach's statement. Walbach cites a 2010 paper published in the journal Science by Edouard Bard, Bruno Hemlin, and Dorian Delange-Sabatier. These scientists used a uranium-thorium method to date corals from cores drilled in the Tahiti Barrier Reef to determine the level of sea rise between 14,000 and 9,000 years before the present. The graph in the publication shows that in the 50 years between 12,900 to 12,850 years before the present, the relative sea level increased by about 3 meters. That is enough water to completely flood the first story of a typical apartment building all the way up to the ceiling. The red line shows the change in delta oxygen 18 in the North Greenland Ice Core project. Delta oxygen 18 is the ratio of stable isotopes oxygen 18 and oxygen 16. The ratio of the oxygen isotopes is commonly used to estimate temperature because it varies directly with temperature. The onset of the precipitous drop in temperature starts at 12,900 years before the present and continues for 50 years until 12,850 years before the present. 50 years is a time span of 2 or 3 human generations. Parents and grandparents would have told their children and grandchildren stories of a very different world because the rapid sea level rise would have certainly caused loss of habitat, destruction of established coastal trade routes, and displacement of seaside communities that depended on fishing. The seashores that were flooded 12,900 years ago are now under about 64 meters of water, which is 210 feet below our current sea level and too deep for recreational scuba diving. In 2007, the Younger Dryas impact hypothesis proposed that one or more extraterrestrial impacts were responsible for the extinction of the North American megafauna and the onset of the Younger Dryas cooling event. Michael Petayev, working with 3 co-authors, examined an ice core from Greenland and found that 12,900 years ago, the level of platinum was highly elevated, as expected for an extraterrestrial impact. This graph shows the platinum concentration in parts per trillion on a logarithmic scale, and the yellow insert shows the same data on a linear scale. Some people have interpreted the 20 years of elevated platinum levels as a period when the Earth was repeatedly bombarded by several extraterrestrial objects, but this is not necessarily so. Following a single large extraterrestrial impact, it could have taken 20 years for all the platinum particles to settle, particularly if some of the material went into low Earth orbit. How can rapid glacier melting be explained at the onset of a cold period? In the case of the Younger Dryas, we have to take into consideration the effect of the extraterrestrial impact on the Laurentide ice sheet and the consequences of the ejecta from the impact. We also need to rely on the phase diagram for water and well-established scientific disciplines of glacial thermal regime, thermodynamics of freezing and crystallization, and solar radiation and the Earth's energy balance. The extraterrestrial impact on the Laurentide ice sheet created a shock wave and transferred a lot of energy to produce water in its three phases: solid, liquid, and gas. The crater produced by the impact displaced material laterally by horizontal compressive forces, and the shock wave sent a blast of hot steam under the ice sheet. We will now examine what happened to the three phases of water. The vapor plume of the extraterrestrial impact on the Laurentide ice sheet consisted of steam at high pressure, which provided additional propulsion to the pieces of ice that were ejected. Water in the gaseous state dissipated into the atmosphere, creating a high-pressure zone. The steam cooled as it expanded and then condensed as liquid water and ice crystals. Liquid water ejected above the atmosphere into the vacuum of space formed ice crystals in low Earth orbit. The crystals increased the albedo of the Earth and reflected the light of the sun back into space. The smoke from fires ignited during the passage of the asteroid or comet could have been cleared from the atmosphere in 20 years, but the ice crystals orbiting 100 kilometers above the Earth could not be affected by atmospheric phenomena like wind and rain. The ice crystals stayed in orbit until they sublimated into water vapor. This process may have lasted 1,300 years, which determined the duration of the Younger Dryas cooling event. The ice boulders ejected by the extraterrestrial impact on the Laurentide ice sheet were launched in suborbital ballistic trajectories with heights of 150 to 370 kilometers above the surface of the Earth and ranges as far as 1,500 kilometers. Oblique impacts by the ice boulders with energies of 13 kilotons to 3 megatons of TNT liquefied on consolidated soil and created inclined conical cavities. Viscous relaxation reduced the depth of the conical cavities to create shallow elliptical depressions known as the Carolina Bays and the Nebraska rainwater basins. This is the phase diagram of water that indicates the states of water at different temperatures and pressures. Of particular importance is the triple point of water, which is the pressure below which water can only be solid or gas. The triple point corresponds to a pressure of 612 pascals, which is the pressure 32 kilometers above the Earth's surface. For this reason, liquid water ejected above the atmosphere into the vacuum of space will immediately evaporate, and whatever remains turns into ice crystals. When the ice crystals in space are heated, they can become water vapor directly in a process called sublimation. Another important part of the phase diagram shows that increasing pressure decreases the freezing point of water. 100 kilopascals corresponds to normal atmospheric pressure at sea level. The bottom of a 2-kilometer thick glacier, like the Laurentide ice sheet, would have had a pressure of about 10 megapascals. This high pressure would have lowered the freezing point of water and favored the formation of liquid water under the glacier. The glacial thermal regime describes how meltwater at the base of a glacier controls transfer and deposition of debris and affects glacier velocities and deformations. The thermal regime depends on air and ground temperatures, with some glaciers being heated from below by geothermal heating. Many glaciers reach pressure melting point, where ice at the base of a glacier starts to melt. In the case of the Younger Dryas, the extraterrestrial impact fractured the Laurentide ice sheet and heated the ground. The warm ground accelerated the melting and transit of the glacier even when the top of the 2-kilometer thick ice sheet was exposed to frigid air temperatures. 80 calories must be removed from a gram of water in order to freeze it, but water can become supercooled and stay liquid below its freezing point before it begins to crystallize. This graph shows that the temperature of liquid water drops below the freezing point until crystallization is triggered by a nucleation process. The temperature then climbs to the freezing point and it stays constant until all the water freezes. When all the water is in the solid phase, it can continue cooling down. The effect of solar radiation on the Earth involves many factors, such as the energy output by the sun, the physical laws governing the transfer of energy through radiation, the distance of the Earth from the sun that varies according to the seasons, the Earth's albedo, which determines how much sunlight is reflected back into space, and the greenhouse effect caused by atmospheric gases that absorb the sun's rays and convert them into heat. As mentioned earlier, the water ejected above the atmosphere by the extraterrestrial impact and water carried by the chunks of glacier ice in their suborbital ballistic trajectories would have created a fog of ice crystals in low Earth orbit that increased the albedo of the Earth and reflected solar radiation back to space. For this reason, the sun could not warm the Earth until the ice crystals sublimated. It is tempting to speculate that the sudden rise in sea level that immediately followed the onset of the Younger Dryas was the result of glacial meltwater released by the heat of the extraterrestrial impact. If so, it may be possible to calculate the thermal energy produced by the extraterrestrial impact by multiplying the heat of fusion of water by the weight of the water corresponding to the 3-meter rise in sea level. Somewhere out there is an oceanographer or hydrographer who knows everything about the bathymetry of the world's oceans and can calculate the quantity of water represented by a sea level rise of 3 meters 12,900 years ago. It is not a simple calculation, but it provides a way of quantifying the Younger Dryas meteorite impact. Thank you for listening to this podcast. Please visit the YouTube channel or the website for many other interesting topics.